Will we get a review?
Hold on. All right, so guys, looking at what people are saying as that they've done the homework, some of you have things written down which look just like answers that come out of the back of the book. These things are effectively proofs. You need to write down the original question and then show a step or two of what you did to get from here to there. Because if it was obvious, because 10 of you showed me just number 1, cosine, number 2, 1, number 3, tangent. If it was that easy to go from one thing to another, then you need, and everyone else is like, oh my goodness, I couldn't even start. There's clearly something you needed to show. So I need them to look more like proofs or have you show more steps. So as it says here, tonight's homework is a delta math where it will help you, lead you through. It'll show you how to get from here to there. And I can put the computer away. That's to do later. So there's a delta math. And if you did not do last night's homework, or if you have just a list of answers, I want you to do it again. Some of you actually showed stuff and I was like, hey, I can see what you did. I understand your steps. Great. That would be like 4 of you. So also writing down number 5, question mark, number 25, don't know. That doesn't count as credit. That's not trying it. You didn't even write down the question. You gotta try something. So today we're gonna try and fix up trig inverse stuff. I will give you back exit cards. The quiz that you are gonna have on Friday, we've done this before. If you do better on the inverse questions on Friday, and you do the reteach that we're doing today, we can replace that 0 out of 6, that 2 out of 6, that 3 out of 6 with what you get on Friday's quiz. So Friday's quiz will have basically the retake, and that's it. This is your one shot, is we'll reteach inverses now, and I'd like you to do better on Friday. But it will also have some simplifying identities, which is effectively what's on last night's homework and this delta. So let's try this. Can you guys get out a notebook? And we're gonna try fixing up stuff. So this stuff, take notes as you feel you need to take notes. Like if you feel you really remember these from last semester, that cosecant is 1 over sine, we'll write it again, that's fine. But you need to know these. So if you don't know them, write them down. You need to know secant is 1 over cosine, and cosine is 1 over secant. And tangent, some of you are not comfortable with tangents, but you're much happier if it turns into sine and cosine. Fine, do that. Cotangent is cosine over sine. Like, I remember this one because co is with co. So if you need to write them down again, do that. But they are identities that we kind of assumed from the past. All right. So on the sideboard above Peter's head and Hall's space, I'm given some ideas of strategies to solve stuff. Yes?
I just want to solve.
Okay. All right. Well, hang on. So strategy number 1 I have up there is if you see pi over 2 minus x or 90 minus x, that's the co-function identities that we did yesterday. If I tell you sine of x equals what? Tycho, if x is 20 degrees, how big is this guy up here? 70. 90 minus 20. Adam, if I tell you this angle, x is 10, what is this angle? 80. William, this angle is 45 degrees. How big is the angle up there?
45.
Mia, if this angle is x degrees, how big is the upper one? 90 minus x. So this is an angle, and 90 minus x is really kind of long, but it is also an angle. So sine of x is equal to cosine 90 minus x. That's the co-function thing.
Oh, I like the way you wrote that.
Okay.
I'm gonna take a photo of that.
Okay, it is being recorded as well. But in these, I don't have one of those 90 minus things or pi over 2 minus things, so I don't need to use that. The next thing I have up there is, do you have any squared terms? Because if you did, then my hint to you is to use one of those Pythagorean identities that we proved yesterday. No squared terms, but if I did see them, I might need to move stuff around here and do some substitution. Last thing is, do you have secant, cosecant, tangent, or cotangent? If so, maybe turn them into the sines and cosines. So, Fernando, what is cotangent in terms of sine and cosine?
Sine over, cosine over.
Monica, do you agree with them? What is cotangent in terms of sine and cosine?
I think
Cosine over
Cosine over sine. Okay. Peter, what is tangent in terms of cosine and sine?
sine over cosine.
Sine over cosine. Okay. So we just made it more complicated, which sometimes that's going to happen. Isabel, does anything reduce? Not exactly cross multiplying, but this thing up top is being divided by that one on the bottom. Alvin, what's cosine divided by cosine? 1. Melia, what's sine divided by sine? So that one just comes out to be 1. Okay, I have 2 cookies, and we're gonna share them. How many cookies do you get? How many cookies do I get? We both get 1. I have 28 cookies. I don't really sound good excited, but I would give you each 1. Like everybody gets 1 stinky cookie. 28 divided by 28. Tycho?
Oh, couldn't you also just make the cotangent 1 over 10? And then...
Okay, so that's the big deal about these things is there's more than one way to go. So he just said cotangent. I know the reciprocal functions. Cotangent I can write as 1 over tangent. And doesn't that reduce to be 1? Sure.
That's a lot easier.
It is a lot easier. And sometimes you don't see that one. So it's whatever you see first. So I have these strategies up here of like, we gotta use the identities. So if you see something ugly like that, pi over 2 minus an angle or something, think about the co-functions. If you see squared terms, think about these guys. And then if you see other guys, so Adam on the sideboard, when I said you saw secant, cosecant, tangent, cotangent, the first thing I said, maybe change it into its reciprocal. That is what Tycho just did. And if that doesn't work, maybe, like for number 2, maybe I need to turn everything into cosine and sine. Johan, how do I do number 2? What's the strategy?
Oh, I think like you can make 1 plus the tangent first.
You should do cosine over sine.
Okay, so should I do the strategy that
You should do cosine over sine because you can cancel out the sines.
all right, so Tycho on the last one said, I'm gonna turn cotangent into 1 over tangent. That's not working so good on this one. And he didn't say it to do with this one,
Oh,
so he's not being silly.
yeah.
Nick
I want
says-
make tangent first.
Come on, Johan.
Nick says turn cotangent into cosine over sine. and it still times that sine value, and you get just cosine.
You don't put the sine into a fraction?
You can do sine over 1 and then you get cosine over 1.
If you need it,
Oh, okay.
that makes you happy.
No, I was not that fraction, I was thinking the one, when you put the 1 over sine.
Or,
1 over
sine is just
okay.
sine.
Never mind, I was confusing.
Alright, so,
So we just ended with cosine.
so we just ended with cosine.
How would you have done it if you're doing it the first way?
I would be screwed. And I'd be like, well, crap, that didn't work.
Okay.
So,
You did.
back up.
Throw that away.
Unless you could do.
So it doesn't work every way.
No, unless you do 1 over opposite. I mean 1 over cosine over. Yeah, that's what I was saying.
Okay,
Are we gonna remove
And then
yeah.
y'all are thinking like puzzles, like.
Okay, guys, so if it didn't work, there are times, like, some of these problems get to be honestly a page long. And it's like, I'm clearly doing something wrong. Like from here, I'm pretty good with fractions. You guys are definitely allergic to them. You don't like them. I want to get rid of this cosine down here. I don't have an equal sign, so I can't do the same operation to both sides. So all I can do is multiply by 1. This is an ugly looking 1, but I get cosine divided by cosine, all of that's in the denominator. And then up top, I have cosine x, sorry, I keep saying x, cosine u, sine u over sine u, which is what you guys started with. I'll still get there, but you guys made the first step harder. Well, just because you see different things. Okay, reteaching this stuff. Genevieve, can you help hand these back out? So, can you guys take out the worksheet on this? And
Most of the class.
we will make sure.
I thought I did better.
I'm about to have tutors
I
tomorrow.
was confused on that last one. I like somehow made like one of the answers
What did you get?
That's about how
Man, what'd you get? You got a 4. Really? Yeah.
What was the outside function? Cosine of?
Dumb mistakes. What did you get? William. What did you get? I got 14. The whole class got a 4.
What's the best score in the class?
6.
Perfect.
Someone got a 7.
Oh, I knew I used this.
Okay.
Raise your hand if you got a 6. We gotta find the hidden genius.
Okay, all right, guys, the thing you just got back, don't write on it. Don't write on the exit card that you just got back. I do want you to do proper corrections. So corrections are done on separate paper with your name on it, and you bring that back with these correct. So you don't need to correct things that you got right in the first place. But, so one question was this. All right, so the way we did these last semester, inside only, sine of 4 pi over 3. Maya, what quadrant is 4 pi over 3 taking us to? 4 pi over 3, what quadrant? 1, 2, 3, or 4? 3, quadrant 3. Okay, so guys, can you look up here? Is sine positive or negative in quadrant 3? Gianna, is sine positive or negative in quadrant 3? Negative, perfect. Okay, so cosine inverse of negative,
I thought if it's a capital S, it could be.
okay, that was not capitalized, but I can do sine, capital or lowercase, whatever. Sine of an angle is just a single number. There's only one choice. There's only one output. Pi over 3, across from pi over 3 is root 3, 1, 2. So the reference angle, Mara, what's the reference angle when it's sine of 4 pi over 3? Reference angle, the smallest one. Pi over, Yusuf, we did this one. What's like the beauty of radians? What's the reference angle? That little guy, just the over 3.
Oh, it's just part of
Oh,
The-
30 degrees.
Oh,
Whatever.
60.
I mean, 60 degrees.
So when it's in radians, it's whatever the denominator is. Pi over, well, I got 3 down there, pi over 3. So Van, what is sine of pi over 3?
Would be
Root 3 over 2. Okay,
Bro.
okay, now it's a different problem. We did, guys, so we did the inside. Where is sine of 4 pi over 3, like what is that value? That value is negative root 3 over 2. Then the outside thing, Miliel, this is cosine of a negative ratio, cosine inverse. Where do I get angles from for a negative ratio for cosine? Quadrant 2 or quadrant 4? Quadrant 2. So I need the angle that takes me all the way over here. It's an angle, not a ratio. So I saw, where is cosine, you're looking at this triangle, where is root 3 over 2, where's root 3 the adjacent?
It's pi over 3. Pi over 6.
Pi over 6.
Adjacent.
Pi over 6, we wanted root 3 to be the adjacent.
Okay.
Okay? So Joey, if this is pi over 6, what is the angle that takes me there? 5 pi over 6. Okay, lots of things in there. First, you needed to be able to evaluate the inside, and a lot of you don't know your unit circle still.
Can we review the one that's cosine of 3 minus 1?
So, what questions do you have on this worksheet? You need to be able to do things like 26. Tan inverse of cosine pi. To me, this is the hardest one on here. Can anyone tell me the process? What do we do? Serene. What do we do first, Serene?
Get cosine pi.
Get cosine of pi. Yes. Okay, guys. Too much chatter. Cosine of pi. Cosine is the x value. Serene just kind of looked up at the ceiling and said, it's -1. Yes, it absolutely is. So then, now it's a completely different question. I did the inside, that was step 1. The next thing, you guys hate this one. What is it?
It's the 45 triangle.
It's the 45, 45, 90 triangle, which in radians, pi over 4s. So what is the reference angle to make tangent 1? Pi over 4. But it's negative.
So it could be on the.
Negative.
So do I, for negative ratios, the angles for tangent come from quadrant 2 or quadrant 4? Which one? Jaleb, which one? No? Yuan says 4.
Oh, it could be.
Maya says 1.
It could be 30.
Gianna says 4. Okay, guys, tangent
Tangent -1 to 4.
comes out of quadrant 4. Is it going to be 7 pi over 4 going the long way around that way, or is it negative pi over 4? So it matters. It matters. Go the short way.
Why would you go all the way around the belt?
Yeah, like, why would you go all the way around the Beltway to go to Silver Spring? Just go the other way. What? Cosine of 7 pi over 6 is negative root 3 over 2. What angle makes sine negative root 3 over 2? We need an angle. So that's negative pi over 3.
This best
Now,
Yep.
this comes together with Reteach, or we still need to go to a different.
No, okay. So I'd like to answer whatever questions you guys have, like what, a lot of you got 4 out of 6. And some of them was a simple mistake because you did Pythagorean theorem wrong.
I don't know how I got square root downstairs.
Okay. And one thing I didn't mark off for it, but I did change the number. What is square root of 169? 13. What?
Center 29, 2 squared is 4.
Secant of, I'm gonna do a different thing. Yeah, well, all right, it does. It's the process. So one's like this. Secant of arctan, 5 over 3. Do the inside first. So, Yusuf, where am I gonna draw the triangle? Arctan, the ratio is positive, so what quadrant do I draw? Quadrant 1? Okay. So, Alvin, how do I label the sides? Opposite is, is the opposite the 5 or is the opposite the 3? So opposite is the top, tangent, and then that's 3. Is the hypotenuse 4?
No, it's not.
It is not.
No.
I need to do Pythagorean theorem. Legs squared plus legs squared equals hypotenuse squared. 9 plus 25 is 34, which is a squared. And as Nick just said, we want the square root, so it's root 34. Okay, so hold on. So again, we just did the inside. I don't know what what the angle is, but I don't need to.
So it's just.
So it's now secant of whatever angle I gave that name of.
So it's root 34.
So secant is cosine upside down. So it's root 34 over what? 3. Some of you guys gave me ratios when I wanted angles and angles when I wanted ratios. Okay. Yeah.
That I got wrong, it was cosine inverse and negative 1 over 2. I got negative pi over 3, but it's wrong.
Okay.
Oh, okay, never mind, I got it.
Because it's pi over 6, but
Yeah.
it's in this quadrant
I
here.
just got that quadrant.
So that's the pi over 6, so you needed,
But it's gonna be 5.
No, I thought it was like, I thought cosine was that way.
Mark,
I'm thinking it's with,
It's not your fault.
cosine 4, and then sine.
sorry, it's just cosine of sine.
Cosine to the, no, to the inside.
So inverse. Cosine inverse.
All right. So just like in algebra 2, you need to take the inside out. So inside is 7 pi, sine of 7 pi over 6. Monica, what quadrant is 7 pi over 6 taking us to? Third. Right. So how is sine positive or negative there? Negative. Renee, what's the reference angle? This tiny little angle right here. Pi over 6. Okay. So, across from pi over 3 is root 3, pi over 6, 1, 2. So, Isabel, what is sine of pi over 6 looking at the triangle? 1/2. So sine of 7 pi over 6, Monica and some I'll say that it's going to be negative because it's in quadrant 3. So now let's replace that. We're doing cosine inverse of negative 1/2. Heiko, what quadrant do negative angles, negative ratios come from?
For cosine?
Yeah.
The second.
Negative cosine angles for ratios come from quadrant 2. So William, gotta be a quadrant 2. Where is cosine 1/2? Looking at this, I want that guy to be the adjacent. Pi over 3 in quadrant 2. So Gianna, quadrant 3, or pi over 3 in quadrant 2, what angle is that? Stop, Gianna.
I was actually the first to say it. Yeah,
Okay, so the last 2 questions on each of your exit cards were the more complicated ones. And many of you got one right and one wrong, so I don't know why. Yeah. Okay, for this one, this is what class is for now, is what are your questions now? So no, you don't need to come into an extra special thing, but you need to do corrections on a clean sheet of paper. So you guys, if you didn't get a perfect paper, which is all but one of you, I would like, not you, I'm so sorry.
Oh, someone was saying
Actually, also, I need you guys to join Delta Math. Can you get out your Chromebook or your phone? I did
That's back in my retake. I want to remember.
Okay.
How is it, it was 5
So this inside was negative 1/2. So that goes away. Where is cosine negative 1/2? Okay. Cosine negative angles come from quadrant 2. The reference angle, I want cosine to be 1/2. Adjacent over hypotenuse, it's going to be 1/2 at pi over 3. I need that pi over 3 in this quadrant, which a whole pi minus pi over 3 is 2 pi over 3. Okay, so guys, go on Canvas, and under the top module that says join codes for Delta Math, join period 3 is Delta Math. Sorry? Go under modules. Because you don't have any other tabs available to you. I eliminated that. So join the class. Okay. So things you should be doing right now, all but one of you should be doing corrections on this, which if you need scrap paper or you need a clean sheet of paper, we can get you some. But you should be doing corrections, and I'd like to hopefully check those corrections before you leave. Don't draw on the original thing itself.
I did not.
Okay. I'll look for it, Serene. So things you should be doing. Join Delta Math. And for the one of you that's completed, and do tonight's homework, which is Delta Math. Those of you who need to do corrections, clean sheet of paper.
It's fast now?
Hang on. For the corrections, you need to copy the original questions. And show where to get the right answer. So show the work to get your answer. And then if you did not complete last night's homework correctly, if you have just a list of answers, so there's 3 things to do. Join the Delta Math and do it. Do corrections and redo last night's homework, all right? Genevieve, can you help walk around and help people through? Okay, so we're, okay, because sine and cosine are restricted.
I wrote it out like this, right? So it's like that turns into one. I got closer to that. So then when you write it out like this, it just, that's. So the answer is be negative 5 or 6.
That's not okay.
Rather than having negative 5 or 6.
So Diana, if I ask for a cosine inverse of an angle, and it's positive, all the positives come out positive. And negative cosine ratios, those angles come from quadrant 2. Sine and tangent are the easy ones, they come out of quadrant 4. So you were saying, where sine negative half, where sine positive 1/2.
So 1 over sine over
Whereas
sine.
a negative 1/2 is gonna come out of quadrant 2. It's gonna be negative pi over 6.
What would it be?
I don't know, they write it out.
I'll put 1 over sine, and then sine here, and I put myself to sine.
Why would sine be over here? You're dividing. Here's your paper.
So, cosine negative 2, cosine 5 or 6, and
Or is it
What's 1/2 divided by 2? 36, right? So that's why that.
Yep, hold on.
Find out 1/2 divided by 2.
Oh, that's it? I don't turn it on. Check it.
If essentially, we're
Yeah,
good,
so you
like,
take the
if
top.
I can get them checked correctly and review one of these back to you now. Yeah.
And multiply it by 1.
Right, I do realize I would like to see a triangle.
sine over
Because of that,
It's not sine.
this guy, yeah, right. This is the same thing, sine 7 over 6.
Top value is not this.
Divided
Divided by
Sine 7 over 6.
or multiplied by 1 over 2.
If you had cosine 5 over 6 is root 3 over 2.
Yeah, but, okay.
So it's root 3 over 2, 1 over 3. So the sine inverse of negative root 3 over 2 would not come out of the third quadrant, it would come out of the fourth quadrant.
Why is this not a
That's it. But cosine of that is not really positive, it's negative root 3 over 2 is not negative. Where it's sine negative root 3 over 2. Yes. Close. So how close? Yeah. You gotta write a pass that is visible.
Where's this?
Not at all. So we're gonna take this.
I got it wrong.
Whereas cosine negative 1 is at negative 7 pi. And this one, sine 4 pi over 3,
Yeah.
with sine 4 pi over 3.
Is third quadrant, so it's 240 degrees. I know that.
Look at it,
so I'm
look at
trying
it.
to
So
read
where
it.
is sine? What is sine? Just pi over 2. Cosine
versus cosine.
Oh, yeah, I forgot.
Cosine of pi over 3.
Yes.
Yo,
Cosine.
Nick.
Negative
So-
root 3 over 2.
Cosine is never gonna be.
Okay, so cosine inverse
So
of
sine
negative
sine
root 3 over 2. Cosine negative angles come from where? From the right.
Cosine is just you have your
Oh.
Restricted cosine
So-
negative ratios.
Oh, okay, so it comes from the second quadrant.
So what angle is gonna make cosine root 3 over 2 and how do I put that in quadrant?
Oh, I get Snapchat.
cosine.
Let me see your.
Yeah, so that's why the bounding is different. You need to make it. You should tell her. Do you have scratch papers on that chart? Okay.
Well, where is cosine negative?
Do you understand what this is?
They're kind of similar. That's only similar.
So if you have.
They're negative in the third quadrant also.
That's correct.
One side.
The second quadrant, so run for 0.
So where you are, wait, let me think about it.
But you want to just write it down.
180, so that's 180 minus
Right.
45.
So,
How do I transfer?
okay, guys, what is the retake for this? It is part of your quiz on Friday, so even if you got a perfect paper, the one of you that is, you will have to repeat your perfect performance on Friday. So part of the quiz on Friday is the identities, and part of them are the,
5 over minus
so,
1.
does that make sense?
Just 35.
So that's how you fix your, so it's like
Okay, I kinda get that.
So if you're probably instead of that.
1 negative root 2, 1 over sine, negative root 3 over 2. How would
So-
you write
The best way to think about it is whatever like the reference angle is, I put that by like the pi.
of negative 1 where sine negative 1?
Yeah, exactly.
So if you were
So if it
to.
was like pi over 6, should I do 6 pi over 6 minus pi over 6? So is it always just gonna be? Now question, why for this like number 2, or you had to do just negative pi over 6, but for this one you had to do everything.
Does that make sense? Sine angles.
See if you can.
So.
Yeah, so anybody who is
So you guys both good now?
says.
Yeah.
No worries.
I didn't write it down. So I have that So I'm not using this.
So
Like, how are you supposed to know time? Would it be on the But is it? I can't do this. So I don't know what I do.
You're trying to go back.
so you get negative pi.
So you know how cosine
So I just have to think about the way.
So cosine.
And since it's already there.
They're negative.
No,
They're
it's
sine.
It goes sine, cosine. If I were to,
So cosine is the.
Yeah. so actually I'll just.
Alright, hold on, let me hit
If I
on.
were to draw mine,
No.
ask you what I,
The first two. Oh, I have to say the entire part. Yeah.
what I would.
So why
Yeah, so the
Was this
negative
just
pi
like
over
a
6
one?
is just saying it's negative pi over 6 cosine. It is literally
So would you, bro?
telling you the direction of the line. Basically, pi over 6 goes pi over 6. Yeah. Yes. I have a question.
It's negative in this one.
Yeah, it's negative in this one. If the negative tells you whether to be clockwise or counterclockwise,
But I have a question. So why is sometimes these questions allow
reference angle is used to simplify math. So I don't know exactly what you're saying. To try and simplify, you're going to use reference angles when it's the axis to try and find triangles, right? Yeah, so a reference angle is the distance between lines, right? So you use this smaller angle to figure out values more likely than not, right? Because it's hard to figure out what 5 pi over 6 is. Right? So that's when you're going to use it. But when she's asking where on the surface is small, then saying the reference angle doesn't try because then the reference angle is never 10, right? Does that kind of make sense? I think that should be right. So if you ask me with more specific example.
all right.
Yeah.
I finished it.
The only thing I like is write down.
Write it out.
Guys, I'm also checking the textbook homework score.
Genius. Oh, I get it. I take it like
I think I'm done. Okay. I just had a question, but yeah, are you good now?
You mess up.
No worries. So, what part are you stuck in? Have you solved the, are you trying to figure out how to start the equation? Or are you trying to figure out how to handle? Okay. So, the first thing you want to do is, if I give you a big gross rate, I give you like 36 times, 12, and then times the first part of that you should solve. Exactly. So it doesn't really matter what this first part is, which is there as well. For example, you want to start with the 2 plus 2. Same thing here. Yeah, the first thing you want to simplify is what's inside the parentheses. So how are you going to solve something 4 pi over 3?
oh my god. Genius.
Is that an opposite sign? Is that not 1 over
Try not to convert it into degrees, only because as you move on in math, degrees stops working. Like, the formulas of math, like the calculations you do are based upon the pi's. So think about it instead of, like, what quadrant would that be in? 4 pi over 3, is that greater than pi or less than pi? Is 4/3 greater than or less than 1? 4/3 is less than 1? No worries. So this is going to be between pi and 2, okay, right? It's going to be on the bottom half of the graph. Is it greater than 3 pi over 2?
Monica, you want like two more things. There's the textbook homework, and there's the donuts. Go pack up.
Right. So that what quadrant is that one?
Okay, if any of you are done the corrections now, I'll take them.
Because it's between pi and 3 pi over 2. So then you solve for as equal to pi over 3, you get that number. But because it's in this quadrant, you know it's negative. Does that make sense?
Yeah.
And then from there, do you know how to handle the cosine inverse?
Yeah.
Okay. Does that make sense?
Yeah.
All right. Fantastic. And then you can let me know next time.
I'll figure it out.
Thank you.
Goodbye, Miss Mascot.
Oh, yeah.
She won't.
There's two more?
No, if you give her quiz corrections. So this one,
What did you say?
that's.
I don't understand how you do that. What is this?
So tangent, cosine squared theta over cosine squared theta. And secant, so let's go secant squared, let's not make it 1 over something, but secant down there, change the name where it's what's its name when it moves up?
So.
Cosine. Yeah, it becomes cosine squared up top. So that's the right way to do it, sorry.
Oh,
That's all right, I
so
thought I already got you checked.
Okay.
No.
Cost was out.
It's not 5
Yeah.
It's actually for the end of that practice.
And it was supposed to be
This
on.
is-
Sorry, but here.
Yeah, it's 0.
Yeah, corrections going up.
Because I saw on the
Understand the 0. It's 0. It's 1, 0. So it's enough